Alright, Mrs. Teasley here. Today we're going to talk about complex numbers. Here in this box I have the definition of a complex number. We start off with an imaginary number, which we represent using the variable I. So what you need to know about I is actually the square root of -1. If you try to type the square root of any type of negative number in a calculator, you'll get an error message. It'll say that it's a non-real number. So we have this variable I that represents the square root of -1. If you take I, the fact that I is the square root of -1, and you square it, so if I square both sides, now I have I squared equals -1. So that's where they get this other definition or equation, I squared equals -1. So we'll be using both of these throughout the lesson. Together, when you put a real and imaginary number together, you have what we call a complex number. All right, this part, this A would be any real number, so this is the real part. And then the part that has the I, the BI, the I beside it, this is the imaginary part. So a complex number is a number, we normally say complex numbers, when you're dealing with imaginary numbers, but most of the time you're going to have like this real part. And if you don't see like a number added to the I, then that real part just happens to be 0. All right, so we'll get more into that later on in the lesson, but let's start off with simplifying some imaginary numbers, or some radicals, we'll say. So this goes back to the last unit where we were simplifying radicals. Now remember what I told you, you can't take the square root of a negative number. So what we would do is, to get around that, I'm going to rewrite this radical as the square root of 36 times the square root of -1. Because we know 36 times -1 is -36. So I just rewrote that radical using a product property. And now I know what the square root of 36 is. The square root of 36 is 6. And now we know that the square root of -1, if you go up here, we can replace that using the variable I. So this becomes 6I. And that's your final answer. So the square root of -36 is 6I. So anytime you have a negative underneath the square root, you're going to end up pulling out an I on the outside of your radical. Looking at the next example, I'm going to do the same thing. I'm going to rewrite this as the square root of 12 times the square root of -1. The square root of 12, I want to rewrite that so using perfect numbers. So I can rewrite 12 as the square root of 4 times the square root of 3. Can't forget that I have this square root of -1 there. I know what the square root of 4 is. The square root of 4 is actually 2. So I have 2. Then I have the square root of 3. And then the square root of -1 is I. So the I goes right behind it. It's not underneath the square root. It's behind the square root of 3. And that is the correct way of writing it. You want to put your I last behind the number. All right, so pause the video. Try example 3. All right, hope you had a chance to try example 3. Let's go over this. Same thing. Now, what I normally do is, as soon as I see a negative underneath my square root, I will just rewrite this as the square root of 98 and put an I on the outside. All right, because I already know that that negative is going to end up turning into an I that's on the outside of the radical symbol. Then again, use what you know about square roots. You want to use perfect numbers. I can rewrite 98 using the perfect number of 49 and then times 2. All right, and then you have that I there. The square root of 49 is 7. I have my square root of 2, and then I have my I. All right, so that's simplifying negative, square roots with negative numbers underneath. Let's look at adding and subtracting and just the different operations with complex numbers. The adding and subtraction is fairly simple. You're just going to combine like terms. The standard form of a complex number is the real plus the imaginary, a plus bi. So you have to write it in that form. The real part has to come first, and imaginary comes second. The I part comes last. If you don't write it in that correct form, then it will be marked wrong. So my lab will mark it wrong, and that's because it's not written in that correct form. And there's more to that. I mean, you can actually graph these, so the order does actually matter. So just remember that. So I'm going to combine like terms. So I'm going to be adding the -2 and the 6. So -2, let me color code it. So -2 added to a +6 is 4. And then I'm going to add +3i plus a -9i. When I add +3i and -9i, I get a -6i. And that's your final answer. You're just combining like terms. Same thing here. I want to get rid of this minus in front of the second parenthesis. So I'm going to put my imaginary one and use the distributive property. So this is 5 minus 12i minus 8 plus 3i. All right, so when I multiply -1 to that second parenthesis, I get a -8 and a +3i. Combine like terms, you want to combine the real stuff together first. So when I add 5 plus -8, I get -3. Then I'm going to add my -12i to a +3i. -12 plus 3i is -9i. And that will be your final answer. So you're literally just combining like terms. All right, getting down to multiplying. This looks fairly simple. 4i times 5i. Well, if I was multiplying 4i times 5i with any variables, you want to multiply the numbers in the front, so there's my 20. And with the variables, you want to add the exponent, so that becomes I squared. But we actually have a value for I squared. Remember, I squared just is equivalent to -1. So your final answer will never have an I squared or any type of higher power of I. The only thing you can have in your answer is just the variable I. So I squared, I can replace as -1. So this is 20 times -1. So that orange stuff, it becomes -1. And 20 times -1 is just -20. So anytime you see an I squared, you need to replace it with the number -1. All right, number 7, -2i times I is -2i squared. Again, an I squared becomes -1. So -2 times -1 is +2. So what happens is, anytime you see an I squared, then I squared just changes the sign of the number beside it. So for example, if I have -30 I squared, that just becomes a +30. All right, so the I squared changes the sign. So I squared changes the sign of the coefficient, so the number in front of it. So if you notice here, we had a -2i squared, but then my final answer, I just get a 2. Above, I had a 20i squared, but notice how my final answer was a -20. So it was 20i squared and a -20. -30i squared becomes a +30. If I had +25i squared, that just becomes a -25. So it's going to be the opposite of the coefficient. So normally, you know, when you start getting more advanced, or we start getting deeper into this unit, anytime I see an I square, I'll replace it with a -1, and that's the reason. I mean, not -1, but I replace it with a -1, but I know that it ends up just changing the sign. All right, we won't move too far ahead, but try pausing the video and use what you know about multiplication to try the next few examples. Try examples 8 through 11. If you don't think you can get as far as number 11, at least try the first two. All right. So I'm going to go through these examples, and again, you know, I'm going to work them out, but I highly recommend you pause in the video if you didn't get to do, you know, 8 through 11. Once I do number 8, maybe pause and try number 8 and try number 9. But here we're just using our distributive property. So we've done this before. 4i times 5 is 20i. And then 4i times a negative 2i is negative 8i squared. All right, first thing is I see this I squared. Remember, I squared is the same thing as negative 1. So when I multiply the negative 8 that's beside it times the negative 1, it becomes 20i plus 8. So again, it changes the sign. This answer is not the final answer because the 8 must come first. The imaginary, that I, should always be the very last thing you put in. So you want to rewrite it in standard form. All right, for number 9, we're going to use FOIL, or the distributive property. I'm going to multiply everything over here by 3 first. So 3 times 5 is 15. 3 times negative I is negative 3i. Then I come back and I'm going to multiply everything in the second parentheses by 4i. So positive 4i times 5 is positive 20i. Positive 4i times a negative I is negative 4i squared. I want to combine like terms. So this becomes 15. Negative 3i plus 20i is positive 17i. All right, so minus 4. Remember, this I squared turns into a negative 1. So that orange stuff is the same. So now when I go here, I have 15 plus 17i plus 4. So notice how originally it was a minus 4i squared, but by the time I get down here, this turns into just a positive 4. 15 plus 4, you want to put that first. That's 19 plus your 17i. This will be your final and correct answer. You want to make sure you put it in standard form. All right. Number 10. I'm going to use the distributive property. 1 times 3 is 3. 1 times negative 2i is negative 2i. Come back and multiply everything over here by negative 3i. So negative 3i times 3 is negative 9i. And negative 3i times a negative 2i is a positive 6i squared. Combine like terms. So this is 3 minus 11i plus 6. Remember, I squared is a negative 1. Which means that that positive 6 that's in front of it turns into a minus 6. Combine the 3 and the negative 6 together first. When you add those, you get negative 3, and you have that minus 11i behind it. All right. Number 11, whenever you see something squared, you want to write it twice. So this is 4 plus I times 4 plus I. So squared, you want to write it twice, and then you do the multiplying. We're using FOIL again, which is the same thing as the distributive property. I'm going to multiply everything in the second parentheses by 4 first. So 4 times 4 is 16. 4 times I is positive 4i. Then I'm going to come back and multiply everything in the second parentheses by I. So I times 4 is positive 4i, and I times I is positive I squared. So this becomes 16. Add these two together, you get a positive 8i, plus, remember, I squared is just negative 1. So this I squared becomes your negative 1. I'm going to go ahead and combine the 16 and negative 1 together, and I get 15 plus 8i. All right. So I'm not going to do number 12. Number 12 is very similar to number 11. You just want to write, actually, the last three are very similar. Number 12, you would just write it twice and then before you multiply. Number 13, I like problems like number 13 because this is what we call a difference of two squares, or conjugates. These are called conjugates. All right, this is the word conjugates. We talked about conjugates before when we were dealing with radicals. And remember, I is a radical. It's the square root of negative 1. So conjugates, how do I know these are conjugates? It looks exactly alike in both parentheses, except one parenthesis has a minus in the middle, the other one has a plus in the middle. What's special about conjugates, I don't have to worry about FOIL. All right, I don't have to worry about the distributive property. If you do A minus B times A plus B, your answer is going to be A squared minus B squared. So with that being said, since I have the exact same thing in parentheses, when I multiply this, all I have to do is take the 7 and square it, put a minus sign, and then take the 2i and square that. So this becomes 49 minus 2i squared. When you square that, you square the 2 first, which is 4, and then you square the I, which is I squared. Remember, an I just becomes a negative 1, when the I squared becomes negative 1. So when I simplify this, I get 49 plus 4, which is 53. So the good thing about conjugates, just like when we're dealing with square roots, and just like here with these imaginary numbers, you're going to always get a nice round number at the end, a rational number. So whenever I multiply conjugates, I'm going to get a rational number, and that's going to be helpful when we get to the next few examples and we start dividing. So pause the video, try example 14. Those are conjugates. Multiply the conjugates, use the shortcut. All right, so here I see this. These are not exactly the same. One has a minus, one has a plus. So now, because one is positive, one is minus, I can use this shortcut. These are conjugates. So it would be 3 squared minus 4i squared. So notice how I put the square on the outside of the parentheses. So this is 9 minus 16i squared. Remember, an I squared just changes the sign of the number, the coefficient. So this becomes a 9 plus 16, which is 25. All right, because remember, I squared, that's just a negative 1. That's how I got that positive 16. All right, when it comes down to problems like example 15, 3 over 4i, you cannot have an I in the denominator. So remember, recall, I is the square root of negative 1. So no radicals are allowed in the denominator. Ooh. So to get rid of it, you multiply the top and the bottom by just I. So I'm going to multiply the top of the fraction by I and the bottom of the fraction by I. When I do that, if I multiply straight across, 3 times I is 3i, and 4i times I is 4i squared. Remember, I squared is just a negative 1. So this is 3i over 4 times negative 1, which is 3i over negative 4. So the way that you'll want to write this is you want to put the negative beside the fraction. This is 3 over 4. And put the I beside the fraction. So the negative beside the fraction and the I goes beside the fraction. That would be the best way of putting this, especially, you know, when it comes down to putting this into the computer and wanting the computer to read it the correct way, this would be the correct form to put it in. So you don't want to leave the negative in the denominator, and you want to put the I beside the fraction, because remember, we want that A plus BI form. So the I goes beside the number. All right, this is one of those examples when I talked about earlier about how it's a complex number. And, you know, I say even if A is 0. So it's a complex number because you have that I there. All right, let's look at number 16. Number 16, the same thing. I have this I in the denominator. That's the only issue. So I'm going to multiply the top and the bottom by I. Now remember, the top has 2 terms. So I have to do I times everything over here. So when I do that, I get 4I minus 5I squared. And in the bottom, when I do 3I times this I get 3I squared. Everywhere you see an I squared, you want to put or replace it with -1. So that's a -1 here. Then I have 3 times I squared, which again is -1. So when I simplify this, I get 4I plus 5 over -3. So even with this fraction stuff, you have to put it in A plus BI form. The real and imaginary has to be separate. They can't even share the same fraction bar. So I'm going to have to break this apart. I'm going to write this as 4I over -3. And then you have this plus 5 over -3. So first of all, this negative I'm going to put beside it. This is a -4 over 3. And the i's beside it. This positive and this negative, this becomes a minus sign. So minus 5 over 3. The only thing is that the part that doesn't have an I goes first. So we need to rewrite this. We need to put this as -5 over 3. And then minus 4 over 3I. All right, you could have saved yourself a little bit of time by just, once you got here to this step, you can just write the 5 first. So you can make this 5 plus 4I and then break the fraction apart. So you won't have to worry about like rewriting it in the correct order at the end. But most importantly, you have to know that you can't share a denominator and you have to put the I stuff last. All right, so number 17 and 18, these are the types of questions that you'll be asked to do when it comes down to test day. You have to be able to do problems like this. So it builds up to this type of problem. So first of all, I have this 2 minus 3I in the denominator. This is the problem that I'm going to use a conjugate. So because I have a 2 minus 3I, I don't just have an I there. I have something added to that 3I. I need to use the conjugate. So use conjugates. So I'm going to rewrite it over here just so I can have more space. So 7 plus 4I over 2 minus 3I. Because I have this 2 minus 3I in the denominator, I want to multiply by the conjugate. The conjugate of 2 minus 3I is 2 plus 3I. So whatever you have in the denominator, you want to use the conjugate of the denominator. Whatever you multiply the bottom by, you have to also multiply the top. So I'm multiplying the top and the bottom of this fraction by 2 plus 3I. So I'm putting parentheses around it because I'm going to do some multiplying. Now, when it comes down to the top part, I have to use FOIL. So I use FOIL or Distributive Property, whatever you want to call it. I need to multiply everything over here by 7 the first time. So 7 times 2 is 14. Plus 7 times 3I is 21I. Then I'm going to come back and multiply everything over here by 4I. So 4 times 2i is positive 8i, and 4i times 3i is positive 12i squared. When I simplify, I'm going to combine like terms. So this is 14 plus 29i plus 12. Remember, I squared is negative 1. So that I squared became negative 1. So this is 14 plus 29i minus 12. Combine like terms, 14 minus 12 added to a negative 12 is 2. So this is 2 plus 29i. That's the top of the fraction. So I did all that just to get the top of my fraction. Now I need to multiply the conjugates. So this is the top. To multiply the conjugates, remember the shortcut, 2 squared minus 3i in parentheses squared. So that's 4 minus 9i squared. So 4 minus 9, remember I squared is negative 1. So that negative 1 makes that a plus 9. 4 plus 9 is 13. So what you have is, if you put this all together, this is the bottom of your fraction. So I have 2 plus 29i all over 13. You cannot share the same fraction bar. So this becomes 2 over 13 plus 29 over 13, and you'll put the I beside it. All right, pause the video and try this example here, the last example. All right, so here we have 5 minus I over 4 plus 5i. Again, I have to use conjugates. So this is 4 minus 5i. Top and the bottom, you're going to multiply by. All right, if this is a plus, you have to use a minus over here. So I'm going to try to be a little bit more neater with this. I'm going to draw my fraction bar. I need to multiply everything over here by 5 the first time. So 5 times 4 is 20. 5 times negative 5i is negative 25i. Then I come back and multiply everything over here by a negative I. So this is a negative I times a positive 4. So when you put that together, you get negative 4i. Negative I times a negative 5i is a positive 5i squared. In the bottom, I'm dealing with conjugates. So I get excited because all I have to do is square the first term, which is 4, put a minus sign in the middle, and square the second term, which is a 5i. And make sure you put the square on the outside of the parentheses. At the top, when I combine like terms, I get 20 minus 29i. Remember, this I squared just makes this positive 5 a minus 5. So we're at the point now you should be able to just change the sign. This becomes 16 minus 25i squared. Again, I squared changes the sign. So at the top, I want to add the 25 and a negative 5, the 20 and a negative 5 together. So when I combine those, I get 15 minus 29i all over 16 plus 25, because this I squared makes it a plus 25. So this is 15 minus 29 over I. Combine those together, I get 41. And you can't even share the same denominator, so you need to split this apart. So 15 over 41 minus 29 over 41, and put the I beside the fraction. All right, and that's it.